Hey everybody, welcome back to some more radical radicals. So we're going to talk about how to multiply square roots and what to do if we see square roots that have variables inside of them and how those reduce. So the first thing, we're still under the same eligible content for the Keystone, the same PA State core standards. So let's just go ahead and move in and do this thing. So let's say you have two square roots and they're going to be multiplied together. Well, that's exactly what you do. However, there might be an outside number we need to deal with, okay? So if you see an outside coefficient type of number, you're going to multiply that with the other outside number. So I always say outside with outside. And then we'll do, that's called like the coefficients. And then the radicands, that's the stuff inside, you multiply that with the other radicand. In other words, the other thing on the inside. So outside with outside and inside with inside. And then you go ahead and you reduce using your list the way that we have been doing. And then you multiply, if there is more than one outside number, you multiply those outside numbers together. When I say outside, I mean like the coefficients. So take a look at number one. I'll just highlight because color coding helps me on this. So the outside 4 gets multiplied with the outside 6 to become, that's the correct color, 24. So 4 times 6. And then let's do green. We do 5 times 30. And 5 times 30, let's see, that's 600, right? Did I do that right? 150, that's embarrassing. Whoa, what am I thinking? Oh, I'm dividing. Sorry. 150, 5 times 30 is 150. Ooh, and now it's time for us to reduce. So can you do me a favor, please? Just drag that 24 down again. And now let's get that list together. I feel like I have so many screens open, but I mean, you're probably used to this by now. There's my list. So what on my list goes into 150? Well, I already know the answer, so what I'm going to do is I'll do a couple bigger than it just to show you why, okay? Remember, you do 150, and then you divide by, let's just do by 100. Then you do 150 divided by 81. Then you do 150 divided by 64. Then you do 150 divided by, and I'm just trying to find one that's not a decimal like we have in the past, 49. 150 divided by, what's next? 36. 150 divided by 25. So there it is. And I'm going to guess maybe some of you already knew it was going to be 25. So when I divided by 25 on my list, I got an answer of 6. So instead of 150, I break it up into 25 and 6. All right, again, just drag that 24 down for me, okay? The 24 gets dragged down one more time, and then I take the square root of my 25, and then it becomes a perfect 5 now on the outside. And I'll write that in green. Maybe I'll write it in pink and green, but that becomes a 5, and then the square root of 6 just stays put. Okay, so we're going to follow this process each time. The last thing I told you to do on this, I asked you to multiply the outside numbers together. Sorry, I meant for that to be a blue highlight because it's kind of like new. We're going to multiply these outside numbers together. So 24 times 5, and that's going to give me 120. And then the square root of 6 just still drops down. So this entire beginning problem becomes 120 square roots of 6. Now, if I type that in my calculator, I just want you to see if anybody's watching this and if anybody cares. That's that as a decimal, and you can verify that you're right as long as you took out that you get the same decimal. So I can say at least I have the same numerical value. Hopefully we took out the biggest square root. All right, so number one, let's get this list. And I want to put this list, if I can manage, I really want to put it in the middle of everything there. I want to put it right there. All right, so number one, 8 times 32. So I'm going to, in my calculator, do 8 times 32. Those are both inside numbers. So I'm going to draw my square root, and maybe just so I stay consistent today, I'll do all my insides in green, just to stay consistent. So I get 256. Now I'm going to look at my list, and I see 256 is on my list. This is a perfect square, so I'm just going to write perfect. So my final answer is just a 16. There was nothing on the outside to even contend with or even to worry about. So just 16 is my final answer. Let me erase that circle and do number two. All right, now number two, anything on the outside I'm going to highlight in pink, which I guess I don't need that highlight. Anything on the inside I'm going to highlight in green. My next step, I'm going to draw a square root. The 2 drops down. The 6 times 24 goes in my calculator, and I got 144. This again is a perfect square root. So I'm going to drop down my 2, and this entire item turns into a perfect 12. So I'm going to change it. I'm going to write dot 12, and 2 times 12 is 24. So my final answer is a plain 24. And I didn't use my list because I knew instinctively that 144 was a 12. Now let's go to number 3. All right, so outside numbers get highlighted in pink. Inside numbers get highlighted in green. At least that's how I'm going to do today. Draw a square root. Is there any number on the outside? 3. Is there any number on the inside? Absolutely. 5 times 216. 1080. Now, there's nothing fancy to do. 180 is not perfect, so I have to use my list. Or 1080, excuse me. So I'm going to do 1080. I'm going to divide by, I'll start in like the 500. So I'll do 529. 1080 divided by 484. 1080 divided by 441. Whoa. 1080 divided by 400. 1080 divided by 361. Just making my way through the list as I've done in previous lessons. 1080 divided by 324. 1080 divided by 289. 1080 divided by 256. 1080 divided by 225. 1080 divided by 196. 1080 divided by 169. 1080 1080 divided by, where it was 69, 144. I'm getting closer. 121. 1080 divided by 100. This is not the only way to do this, but I mean, like, this is that one way that works all the time. Where am I at? 64 now? All right. Wonder how frustrated kids are going to get in class with this one, because I'm like over it. I like to show you the steps as to why it works. There is absolutely different ways to do this. I think it's 36. I think we're finally there. Oh, okay. So it's 36 and 30. So I keep my 3. I turn this into a 36 and a 30. And now I'm just going to shrink this down. Okay, the 3 stays a 3. The 36 becomes a 6, and I'll multiply those, and the square root of 30 stays. Last, the 3 and the 6 becomes an 18, and the square root of 30 drops down. That one was definitely more challenging. Let's do number 4. All right, so outside numbers are going to get highlighted in pink. So -5 times -3. I'm just going to do that now. That's positive. Oh, my dear heavens. -5 times -3 is positive 15. So that's my outside number. That's my positive 15. Here, I'll draw arrows just in case that helps you see it. And then my inside numbers, something's going on with my pen. I'm sorry, guys. 21 and 42. That's 882. So I'm going to draw square root of 882. And like that's good, but now I have to use my list. So 882. 882 divided by, I'm going to go to 484. That's going to be a no. 882, and I'm going to divide by 441. That's going to be a yes. There it is. So instead of 882, I need to see 441 and the square root of 2. So what I'm going to, I had to, this wasn't perfect, so I had to use my list. And then the 15 drops down in front. All right, now let's drop down that 15 again. The 441 turns into a 21. That was supposed to be in green. I'm sorry, it's trying to stay color. So that turns into a 21. The square root of 2 drops down. And now I'm going to shrink some of this down, just this stuff right here. And I need to put together, on my last step, 15 and 21 is 315, and the square root of 2 drops down. And that's how you simplify that one. Okay, let's try this again on number 5. Outside numbers, I am going to highlight in pink. And I'm going to put them in my calculator right now so I don't forget about them. You get an 8. I'm just showing you how to do the calculator. It's not that I can't. I just want to make sure that if you can't, that like, you can't say like, oh, Miss Langella never showed me how to use a calculator. Okay, so now it's going to be 10 and 90. So 10 times 90. And if you don't know, like just use your calculator, okay? Don't sit there and guess. Don't sit there like twiddle your thumbs. Just do it, okay? Use your calculator. That's why I'm giving it to you. All right, drop that 8 down again. So you multiply outside and outside, you multiply inside and inside, you drop the outside and you break up the inside. It's not perfect, right? I'm gonna write not perfect. So, oh, that was a big fat lie. It is perfect, Mrs. Langeli. Boo hiss. It is perfect, silly me. The square root of 900 is 30. So I'm gonna write that it is perfect. I'm gonna pretend like I didn't make that silly dumb mistake. And the square root of 900 is just a 30 with no leftovers. So my final answer is just 240 because 8 times 30 is 240. There's no square roots left over because it was perfect. Nice. Let's do number 6 now. So pink is for my outside numbers today. Tomorrow maybe I'll do something different. Inside numbers are green. So I'm going to get my pink. I'm going to multiply negative 9 and 2 to get negative 18. Again, if you don't know that that's negative 18, that's why you're allowed to use a calculator in my class, okay? It's totally fine. Totally fine. And then square root of 18 times 98. Let's see. You and I would use a calculator there. So 1764. This is not perfect. This one is true. That one's really not perfect, so I need to use my list. So I'm going to drop down my negative 18. And I am going to break this apart. And now I need to go to my list and figure out what I'm just going to start at 841. So 1764. It is not 841, but I'll just start there, okay? So not 841. So it's that one divided by, what do I divide by now? 784. Nope. Now what do I divide by? 729. Nope. Now what do I divide by? So no, 676. Oh, I didn't get it, darn it. 1764 divided by 676. Hey, I'm recording a lesson. You want to say hi? Oh my gosh, now they all know who it is. 1764 divided by 625. What is it? 1764. See, some kids like me. Divided by 576. I don't get angry at me about this, okay? Get angry at math. Go ahead and get angry at math, but don't get angry at me. 1764 divided by, yes, there is a different way to do this, but it can get really involved and really complicated. This is just like an annoying process, but it's not a complicated process. It's just annoying. Plus, I didn't type it in right because I'm talking. Yay! Thank gosh I tried it. I saw that. All right, so when I divided by my perfect square of 441, I ended up getting a 4? So you're telling me this is perfect? Oh, that's so annoying. Bah humbug. Oh well, I'll show you what to do. Ay, 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 ay. So the negative 18 drops down. I guess it didn't look perfect because it wasn't on my list, huh? 441 is, what's the square root of 441? It is 21. Oh, nobody's gonna like this. They're gonna get mad at me. And the square root of 4 is 2. So these were actually perfect, both of them, which is, I guess I never even checked at the beginning, did I? 1764. Oh well, I'm not gonna sneeze at it. That's fine. So this is really negative 18. What a waste of time that was. Times 42, which ends up just being, what is negative 18 times 42? Negative 756. All right. Ay, 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 that was crazy. All right, so hopefully you multiply your outside numbers together, you multiply your insides number together, and then you see if it's perfect, and see if it's perfect, and then after you check if it's perfect, then you use your list. Okay, in the middle of teaching my lesson, I decided that we are going to take 2 days. We're going to do one day for the variables and one day for the multiplication. So if it seems like I cut out really weird there, I did. So let's go ahead and review something from your chapter 3 notes, okay? This is when you were solving absolute values. So that's what these bars are. They're absolute value bars, okay? Something you need to remember about these if they have two answers. I have seen in every practice keystone test that I've seen absolute value problems on there. Okay, so I wouldn't do it if I didn't think you need it. So I'm going to write the word and here because there are two answers. So the first equation you get from this is your regular equation without the absolute value bars. So 4n plus 2 equals 34. If we solve that basic, we take away 2, and we get 4n equals 32. If we divide both sides by 4, we end up getting an n equaling 8. Now that's just one answer. Remember, absolute values have two answers. The other answer is sneaky, but we can do this. You keep your 4n plus 2. You flip the 34 to a negative 34, and you solve that. That's because absolute values can be positive and negative and give you the same answer. So there's your 4n. Here's your negative 36 this time. Divide by 4, and n is negative 9. I will tell you, I've seen tons of kids get the negative 8 and then just assume, or get 8 and assume the second one's going to be negative 8. Please don't be that type of student, okay? Actually solve it out, all right? So there's two answers. Let's try that again. And it won't like, the keystones won't like tell you like, hey, remember there's two answers. You're going to have to do that, okay? It's multiple choice though. Hopefully you see like, oh, each one of these has two answers. So the first one is negative 2v take away 5 equaling 17. And negative 2v take away 5 equaling negative 17. So there's your two equations. Just remember, you set it equal to the opposite on the second one. And now we solve using your normal algebra 1 skill. So we'll add 5. Negative 2v equals 22. Divide by negative 2. V is negative 11. That's your first answer. Now let's do this one. Add 5. Negative 2v equals negative 12. Divide by negative 2. V is 6. Again, you're going to get two separate answers. If this one's negative 11, please don't assume that one's positive 11. If you want to check if they're solutions, because I truly believe that you should know what in the world you're doing. If you plug 6 in here, you will get a 17. So if you did the absolute value of negative 2 times 6 minus 5, you will get a 17. Because negative 2 times 6 is negative 12, take away 5. Negative 12 take away 5 is negative 17, and the absolute value of negative 17 is positive 17. The same thing would happen as if you plugged in negative 11. You would end up getting, well here, and I'll show you. You would get negative 2 times 11 minus 5. And I'm going to show you get 17. So you get negative 22 minus 5. Positive 22 because you're plugging in negative 11, silly Mrs. Angeli. So that would be positive 17 when you add those, equaling the absolute value being 17, and those are both true statements. So that was just a little memory recall back from chapter 3.